Okay, let's see how we did on these. So for this first one, what's the first thing we would have to do to solve it? Add 11. And again, we have to do the exact same thing to both sides. So 7x equals 70, and then divided by 7. X equals 10. And of course, if you wanted to, you could always double check. 7x becomes 7 times 10 minus 11. So 7 times 10 is 70, minus 11 is 59. Over here, what do we need to do first? Add 4. So 50 equals 2y squared, and then divide by 2. So 25 equals y squared, and then square root. Y equals 5 or negative 5 if you wanted to be picky. This one, what do we do? Subtract 9. So 4 equals z over 3, and then multiply by 3. 12 equals z. Over here, subtract 1. 8p equals 48, and then divide by 8. P equals 6. How many of you had all 4 of those right? Good deal. Well, since we're in the review mode, let's review something like this. How do we do something like that? Well, you start out with the number. You're going to take 4 to the 4th power. What's that going to be? 256. Yeah, 4 times 4 times 4 times 4 is 256. But then what do we do with the variables? Yeah, so the power gets multiplied. So x to the 5th to the 4th power ends up being x to the 5 times 4 is 20. Y squared to the 4th power is y to the 8th. Z to the 3rd to the 4th power? Z to the 12th. What do you think? Good. How about something like this? Again, we got the 3,125. We actually have to take the 5th root of that, which will be 5. Very good. And then for each of the variables, what do we do with their powers? We divide by the index of the root. This is a 5th root, so the powers are divided by 5. So x to the 35th, 5th root of that will be x to the 7th. And then y to the 20th, the 5th root of that will be y to the 4th. Okay, a separate sheet. If I gave you something like this, what would you do with it? Just throw it away and run. Get the wrong answer. Well, this is just the order of operations. So we're looking, we have parentheses first. Is there anything we can do inside this set of parentheses? Say no. But there is something we can do to it. We can multiply by the 4x. So 4x times 8x is 2x squared. 4x times negative 5y negative 20xy. Very good. Other set of parentheses, anything to do inside that set? No. And it needs to be done to that set of parentheses. Yeah, times 3y. 3y times 6x is 18xy. It's positive, so I'm going to put plus 18xy. 3y times 5 plus 15y. Nothing else to do with the negative 3y and positive 5x squared. Now we can combine, no more multiplication or division, but we can combine with addition and subtraction. 32x squared and 5x squared make 37x squared. Negative 20xy and positive 18xy make negative 2xy. And 15 and negative 3y make positive 12y. There it is. Any questions? Okay. Well, there's some of you still working on the quiz. And as always, feel free to take as much time as you need to finish up. I want to take some time to start our new material. We started yesterday solving equations like we did with the first couple of problems today. I want to take a look at what happens when things get just a little bit more complex. We can end up dealing with things like this. Now here, as always, we find the equal sign, and we identify where the variable is. The variable's on the left side. And as we're doing that, we notice that our variable appears twice. We have a 5x and we have a 2x. Now remember, these equations are basically a balanced scale. And right now the 5x and the 2x are on the same side of that scale. So if I just push them together to make one big pile, would it change the balance of this scale? No, it shouldn't, should it? So I take the 5x and the 2x and push them together to make 7x. So on the left side of the scale, what I really have is 7x minus 2. So I've combined the two different x's, the 5x and the 2x, into a single term of x, 7x. So now it's just like some of the equations we solved last class. That is true on any equation. I can combine and simplify anything on one side of the equal sign and the other side. I just can't cross over the equal sign to combine and simplify. But I can do whatever I want on each side separately as far as simplifying and combining. Now then, to solve this, I'm going to add 2. So 7x equals 28. And then divide by 7. So x equals 4. Now compared to that, this one is similar but different. What's the big difference there? Yeah, the variable appears twice, but this time one is on each side of the equation. 5x is on the left and the 2x is on the right. I can no longer just push them together to make one big pile because I'd have to cross over the equal sign. I have to go from one side of the scale to the other. So in this case, what I need to do is just get rid of one of them. Literally grab onto it and pull it off and throw it away. Now usually I get rid of the smaller one because that's the easier one to do. How do I get rid of something mathematically? Well, it's 2x. If I subtract 2x, it is gone. I have 0. I'm taking it away. But I just took 2x off of one side of my equation, of my scale. It's going to tip unless I take it off the other side. Now on the right side, all that's left is the 25. I took away the 2x. On the left side, I have the 5x and I have the negative 2. Which one can I take 2x away from? The 5x. I can only take it away from things with the same name. So I take 2x away from the 5x to give me 3x, and I still have the negative 2. Now what do I do? Add 2. So 3x equals 27. Divided by 3 x equals 9. Perfect. In your notes, try that one quick. Where do we start? Okay, we have the x appears twice again, but it's once on each side, so we have to get rid of one. The smaller one is the 7x, so we subtract it. So here we have negative 2 equals, taking 7x away from 9x gives us 2x minus 34. And then add 34. So 32 equals 2x. And then by 2. 16 equals x. And as always, you can go back and put 16 in for x and test to make sure it worked. 7 times 16 is 112. Minus 2 is 110. 9 times 16 is 144. Minus 34 is 110. That's it. I like it when it turns out, huh? Let's see here. Try that one quick. So for this one, what are we going to do? Combine like terms. 5x and 2x makes 7x. Still have the positive 3 equals 48. Then what? Subtract 3. 7x equals 45. And then dividing by 7 gives us 6.42857142286 approximately. Close enough? Okay. I can keep going a few more digits if you need me to. Well, the calculator gave up early. Quitter. Actually, technically, yeah, you could do this. Cut it off at the 1. Those 6 digits will repeat over and over. So anyway, we can also run into things like this. Now, of course, what's different when we look at this one? Well, we haven't seen those parentheses in one of these before. Parentheses always should scream at us, do something here first. Well, in this case, is there anything to do inside the parentheses? Say no. No. But there is something that can be done to the parentheses. Remember, that's always the second question. If we can't do anything in the parentheses, can we do anything to the parentheses? So yes, we're going to multiply by the 5. 5 times 2x is 10x. And 5 times a negative 7 is negative 35. Equals 15. Then what? Add 35. So 10x equals 50. And then divide by 10. X equals 5. What you think? Good stuff? Okay. Try that one in your notes. Where do we start? 3. We do the 7 times the 3x plus 1. 7 times 3x is 21x. 7 times 1 is positive 7, so plus 7. From there, what do? Subtract 7. 63 equals 21x, and then divide by 21. 3 equals x. Take this minus 1 off of here. There. Since you see, I seem to be doing so well with all this, let's step it up a notch. Try that one in your notes, see how it goes. Looks like a couple of you have it done. So we said we could work on each side separately and reduce as much as we can. So over here, we've got 5 times the 3x minus 1. So 5 times 3x is 15x. 5 times negative 1, negative 5. Now this next one is where the mistakes usually get made. This is not the 2x plus 1 times 2. It's 2x plus 1 times negative 2. So negative 2 times 2x is negative 4x. Negative 2 times 1, negative 2. Now I can still combine 15x and negative 4x make 11x. Negative 5 and negative 2 make negative 7. That is the left side of my equation. On the right side, 3x times the 2x plus 3, 3 times 2x plus 3. 3 times 2x is 6x. 3 times 3 plus 9. Over here, 2 times 5x, 10x, so positive 10x. 2 times negative 13, negative 26. Then we got the minus 5x. So now we got 6x, 10x, and negative 5x make 11x. 9 and negative 26 make negative 17. Now what? Get rid of 11x, right? So negative 7 equals 17. Is that true? No, our variable's gone, right? Variable disappeared. So there's only 2 cases. There's only 2 possibilities. The one possibility is that no matter what x is, this is going to be true. If the number on this side and this side were the same, then the value of x wouldn't matter. No matter what value you put in there for x, this equation would have been true. Now in this case, however, those 2 numbers are different. Negative 7 and negative 17. If they are different, is there any value I can give to x that'll make negative 7 equal negative 17? No. There is absolutely no solution to this equation.
So how would it work on the graphing calculator?
Graphing calculator wouldn't do it. It would freeze up.
Because I had this thing in high school where you could create lines.
The solver?
Shade on either side.
Yeah. Well, this one wouldn't be a line anyway because it's just a single value. It's a single variable. To create a line, you have to have 2 variables.
Right.
Okay. We'll give you guys something to play with. Big book, page 378, says 14-9. Page 380, it says 14-10. Page 386, it says 15-1. And page 389 through 390, exercise 15-3. We are going to take more time tomorrow to go over some more examples of these, maybe do some more complex examples, and play with them a little bit more. Word from Brandon and what he's doing.
Hasn't texted me.